In Eantime there are three types of exceptions, each with their own way of dealing with them. Programming and environmental exceptions. Numerics exceptions. Hardware faults. Exceptions may be handled inline, i.e. by checking for the result of every kernel call, both for high-level and low-level objects. You also may use SEH, structured exception handling as defined by Microsoft and familiar to many developers, or the C++ style try/catch structure. SEH got enabled in Eantime 4 and starting with Eantime 6 also is enabled for numerics exceptions. SEH is the recommended method for new applications. The Eantime for Windows configuration also can watch for Windows terminating either by a Windows stop exception, also known as blue screen, or a Windows shutdown, allowing real-time activities running in Eantime to continue or orderly terminate. Finally, Eantime has a configurable function fault handler that continuously monitors the system, reports faults and allows autonomous or interactive reaction and diagnosis of faults. Eantime's kernel enables the successful operation of real-time threads even in the event of a total Windows failure, also known as a blue screen crash. Failure diversion. Eantime capture Windows failures. Once captured, Windows is suspended, control transfers to Eantime's real-time kernel, and real-time threads continue to run, unaffected by the failure. Application-specific recovery. In the event of a Windows failure, your crash recovery real-time threads run and you can carry out an orderly shutdown of the hardware your application controls. The basic mechanism to handle a Windows crash is that the Eantime kernel catalogs an object with the name nt_crashed in the root object directory when a crash occurs. Any RT thread can wait for that event, using lookup RT handle. When a thread does its first printf after a crash, it directly writes to the screen in text mode. For more information, see the sample project Windows Stop Detection Sample, StopMGR. Programmer exceptions are caused by providing incorrect parameters to a system call. Environmental exceptions occur when the environment cannot provide the requested resource, such as trying to allocate memory when none is available or trying to receive data from a mailbox where you do not have a handle. By default, all exceptions are handled inline in the application's source. In the example, the call returns a success or failure value and getLastRT error is used to obtain the exception code. If a system call returns a result that indicates an exception, all other output parameters of that system call are undefined. Structured exception handling is a Microsoft-specific extension to the C programming language, implemented by Microsoft Visual Studio. It allows a C program to deal with hardware and starting with Eantime 6, numeric exceptions in a structured way. A block of code is enclosed in __try and then followed by an __except block. If an exception occurs in the try block, the filter expression in the except block is evaluated and as a result the except block is further executed or an embracing except block is tried. If a try block is successfully executed or if an except block is executed, execution continues after the try except sequence. The finally option makes sure that no matter how the try block finishes, the code in the finally block is always executed. A try block can only have one except or finally block, but they can be nested as required. Self-raised exceptions are generated by the raisException function. RaiseException enables a process to use structured exception handling to handle private, software-generated, and application-defined exceptions. A filter can be a constant as indicated above, but it can also be an expression, such as a function call, that results in one of these values. Inside the filter, a number of special SEH functions may be used. GetExceptionCode returns the exception code, such as exception_access_violation. GetExceptionInformation returns a pointer to a exception_pointers structure, which in turn contains pointers to an exception_record and a context. RaiseException can be used to test the handling of an exception, or to generate a custom exception. See the Win32 or Eantime help for details. This function is a bit outside of the scope described throughout this chapter. Many applications that are tested and launched must not fail and should never experience an exception that is not handled by the application but triggers the fault handler system that is there as a sort of last resort. However, the fault handler is very useful and convenient during integration and as a means of diagnosis during development. Find details on the fault handler in chapter Diagnosis and Integration of this training. Note, since structured exception handling was generally enabled in EanTime 4, and enabled for floating point exceptions in EanTime 6, it is no longer recommended that you use explicit exception handlers. A numeric exception occurs when floating point calculations give an improper result, such as a floating point divide by 0. SSE instructions also can result in numeric exceptions. Such exceptions can be handled by an exception handler. While the system always provides an exception handler with standard functionality, a thread can set an individual handler customized for its specific requirements. Handling hardware exceptions is a bit different. There is a fixed handler in the system. This handler can be configured by setRTExceptionHandler. In case of a hardware exception, a message is sent to the data mailbox, whose handle is cataloged as HW_fault_MBX, and then the system hardware handler is executed. The mailbox name is looked up in both the current process and the root process and the message is sent to both, if present. There should be exactly one thread waiting at such a mailbox, or else the waiting threads will take turns. The spin doctor was intended as a safeguard when using EanTime shared mode so that Windows would not freeze because of an spinning thread in EanTime. Spin doctor writes a fault record to the HW_fault_MBX so it can act like a real fault, even though it is not. The spinning thread is suspended just before the record is written. The spin doctor is subject to some rare false positives, when EanTime is running in dedicated mode and is not intended for a production environment.